Let's take this blank whiteboard and design a cheap and scalable backend architecture for my tech startup. By the way, if you're new here, I'm Addy, and this is episode 6 of a series where I'm challenging myself to build a startup from scratch over 90 days and document everything on this channel. So, if you'd like to follow my journey, then hit that subscribe button and check out the rest of the videos in this series. Okay, let's start off by thinking about how this app will work from a user's point of view. I'm building a video processing application that basically pre-processes raw footage for social media in one shot. So, the first thing a user would need to do is upload their file to the backend server that I'm building. Once the file is uploaded, they'll define a set of processing actions that they'd like the server to do to their raw footage. This is stuff like noise removal, audio enhancements, color grading, and so on. From there, the user will click on a button that'll begin processing their uploaded file, and the user will basically wait until the processing or the job is done. Once the job is done, the server will return a download link which the user can then click on to download their processed file. So with that flow in mind, let's tackle the first problem, which is allowing a user to upload their raw footage to the backend server. Now, video files for content creation can be massive in size. How big? Well, the raw footage for this video that I posted earlier on was about 5 gigabits in size and was around 30 minutes in length. Now, I could store a user's file on the backend server that I'm building, and it might work fine if maybe 5 or 10 users upload their files to the server at the same time. But what happens when 1,000 or 100,000 users try to upload a 5 gigabyte file to the server at the same time? Well, a few problems would arise. The first is that the server would quickly run out of storage space trying to handle all of these large files simultaneously. The second issue is that the server's network bandwidth would quickly become a bottleneck, causing slow upload speeds and potential timeouts for users. The third problem is that the server might run out of memory while trying to process all of these concurrent uploads. This is why I've decided to offload file storage for my application to Amazon S3. S3 provides virtually unlimited storage and automatically scales to handle any number of concurrent uploads. What's even better is that S3 can automatically delete uploaded files, say after 1 week, so I won't need to implement any code for that. Plus, I only pay for what I use, so if I delete uploaded files after a certain period of time, I should be able to keep my file storage costs pretty low. And with that in mind, this is how the backend will handle file uploads. When a user requests to upload a file, their client will access an endpoint on the backend server that I'm building, which is going to be called request upload URL. This endpoint will generate a unique S3 signed URL and return that back to the client. The client will then use that signed URL to directly upload the user's file to S3, meaning that users' files no longer have to go through the backend server. We'll also store some metadata about the file that was uploaded into an SQL database that our server will connect to. And with that, I should have a pretty robust architecture for large file uploads, which means that I can move on to the next problem, which is processing a user's uploaded file. Now, once the user has uploaded their file to S3, they'll be able to define how that file should be processed with the help of some UI on the front end. The end goal of this step is to have maybe an array that contains a set of processing tasks that the user would like to perform on their uploaded file. Once this has been defined by the user, they can click a button to trigger the processing of their uploaded video file through an endpoint called trigger job. This endpoint will store information about this processing task as a job into an SQL database and will return a job ID back to the user's client. We'll also have another service, which I'm calling the filter service, that periodically checks the SQL database for jobs that haven't been started. If a job is found, the service pulls that information about that job from the SQL database and also pulls down the raw footage from S3 for that job. From there, this service will begin processing that raw footage using a variety of video processing algorithms and machine learning models. And once it's done, the service will upload the processed footage back to S3 and update the job status in the SQL database to done. And while all of this is happening, the user's client will use the job ID that it received earlier to continuously poll our backend server to check the status of the job it triggered. If the status is pending, then the client does nothing and polls the backend again after a certain period of time. But if the job is complete, the backend server sends a signed S3 download URL for the process footage back to the client. The client can then use this URL to directly download the file from S3 to the user's machine, meaning that our server does not need to directly support file downloads. And with that, we have the initial architecture for this application. But you might be wondering how this would even scale to handle more traffic. Well, we already spoke about how S3 automatically scales to accommodate concurrent requests and large file uploads, so there's nothing to be done regarding uploading and downloading files. But for the backend server, if we do notice an increase in traffic, we can horizontally scale it by spinning up additional server instances. We can also add a load balancer on top of these instances to distribute incoming requests evenly across all of these servers. To scale our filter service, we can once again spin up different instances that will each process different videos. We can also add another layer on top of this called an autoscaling group, which will basically check the number of pending jobs in the SQL database and spin up additional filter services to handle those jobs. So yeah, after all of that, this is the initial backend architecture that I'll be going with for V0 of my application. I know there are probably a lot more optimizations that can be made, but I'll refine things later on as I learn more about how users actually interact with the application. But for now, I think this architecture gives me a solid foundation that can actually handle growth while keeping costs manageable. Cool. So if you like this video, then smash that like and subscribe button to help boost it on YouTube. Thanks for watching, and I'll see you guys in the next one.